Welcome to our Team Teach. This is the Unstoppables. Today we're going to talk about algebraic reasoning, graphing, and connections with geometry. So for question 1, we're going to open with Allison. Create a graph that represents the height of a bouncing ball dropped from a table.
Okay, so if you notice, my x-axis is the number of bounces. My y-axis is the height of each bounce. So here we drop the ball from the table. It goes down and bounces up and down and bounces up again. If you notice, the second bounce is not as high as the first bounce, and so on and so forth. With each bounce, the height is shorter and shorter. And then eventually the ball is just going to roll and then come to a complete stop.
Good job, Allison.
Thank you. So Elizabeth, can you create a graph that represents the movement of walking downstairs?
Yes, ma'am. If you'll notice, on our x-axis, we have distance traveled, and on our y-axis, we have walking downstairs. With every step you walk, you pretty much walk flat straight across the step before you dip down to your next step. So that movement is going to look something like this, like a step, because that's pretty much the movement that you're following as you go down them. So with every step you take, eventually you're going to have a line kind of like this, and it pretty much demonstrates that the farther you travel, the lower you're going to go as far as your flight of stairs goes. Now, Molly, show the graph. Oh, thank you. Molly, show the graph that matches the function of the amount of gas in a gas tank when a driver refills the tank on a drive across the country.
Yes, okay, so as you can see, we have the x-axis labeled distance traveled, and then over here on the y-axis, this is actually going to be labeled gas in the tank, and this is because at this first point right here on the graph, at the start of the line, you can see that it slowly begins to decrease, and then at this point right here where it stops, that is actually there to represent the driver stopping to get gas. That is why it does not move any on the x-axis, but rather it moves straight up on the y. And then again, once he starts driving, the gas is slowly running out of the tank, and that is why the slope is going downwards.
Good job.
Thank you. Okay, Miranda. Show and explain a graph to correlate with the function of the length of a shadow of a flagpole length of a shadow of a flagpole throughout a sunny day.
Okay, so we're gonna have to do our distance formula. The flagpole is 6 feet tall, so that's why our coordinates are 6, 0, and the shadow of it is 3, -4. And we're gonna have to fill in our distance, which is x times z minus x minus 1 squared plus y times z minus y minus 1 squared. So then we fill in our coordinates, and we're going to get d squared equals 3 squared plus 4 squared equals 25. And then we're going to have to square root 25, which is going to give us 5. So 5 is the long distance right here. That's where our 5 comes in. And then down here, we're going to do 6 minus 3, which is going to give us 3 on our x-axis. And on our y-axis, we're going to do 0 minus 4 equals 4.
Good job.
Good job.
Okay, so question 2. Elizabeth, solve for f(gx) if xf equals 4x and gx equals x minus y. Give that x equals 1.
So what we're going to do, we're going to start out with our initial equation, f of g of x. We're going to want to plug in 4x for our f and x minus 2 for our g. So when we go ahead and we plug those in, we're going to have 4 times 1 times 1 minus 2. We're going to go ahead and follow the rules of PEMDAS, do what's in our parentheses first. 1 minus 2 is going to be -1. And then we're going to do, my screen went black. There it goes. And then we're going to do 4 times 1, which is going to be 4. Next, we're going to do 4 times -1, and that's going to give us a solution of -4.
Good job, Elizabeth.
Thank you. So Allison, solve for g of f of x when x equals 2, f of x equals 3x, and g of x equals x plus 8.
Okay, so I created this little table to organize everything and give you a visual of what's going on. So my x is 2, f of x, which equals 3x, and then g of f of x, which equals x plus 8. So I'm going to start with my f of x function, and I'm going to plug my in. So that is 3 times 2, which gives 6. And then I'm going to take my 6 and plug it to my g of f of x function. So 6 plus 8 is 14.
All right. You did really good, Allison.
Thank you. Molly, solve for fg of x if f of x is 2x and g of x is x plus 3 when equals 3.
Okay, so for this one, you are using basically just the same methods. You're just plugging in those numbers for f of x, g of x, and x. And so right here, we've got the original equation, f of g of x equals 2x times x plus 3. And then you're going to start your plugging in. So right here, we've got all of the values actually plugged into the equation. And so that is actually going to become f of 3 equals 6 times 6. And this is because you've got x equals 3, so you're just simply plugging in that value. And so that's where f of 3 comes from. And then that becomes essentially 36. And so over here, I also created a table just to give you the final values of x, f of x, and g of f of x. And they are all right here in the table.
That was
Great job.
Thank you. Okay, Miranda, can you show and explain g of f of x for x equals 0?
Yes, ma'am. Okay, so we're going to plug it in. So g of f, we're going to put 0 in there for our x value. And then we're going to bring down 3x. And so 3x times 0, well, 3 times 0 is 0. And then we're going to put 0 in our x. And then we're going to do our add 8. And 0 plus 8 equals 8. So that gives us 8.
Good job.
Oh. Okay. So we're going to go to question 3.
Miranda, what is the slope formula? Show and explain the slopes of the line segments determined by the given points.
Okay, so our slope formula is going to be m equals y2 minus y1 over x2 minus x1. So our points, P is x1 and y1, and then Q is x2 and y2. So what we're doing is we're going to fill it in. So x1 is 5, x1 is 5 minus 1, and then that gives us 4. And then over here, we got 5 minus 3 equals 2. See, if we come over here, our slope is going to be 2, and it's going to be upwards. And where our y2 and our y1 over here, we have them minus 5 minus 3 is 2. And then when you come over here to your x's, you have the 5 minus 1 is 4. So we're going to go to the next question.
Good job.
Thank you. Elizabeth, how do you determine the slope of 2 given points using A12 and B47 as an example?
So like Miranda said, our slope formula is going to be y2 minus y1 equals x2 minus x1, or over x2 minus x1. We're given 2 points, A and B. Our points for A are 1 and 2, which is going to be x1 and y1, and then our point for B is going to be 4, 7, which is x2 and y2. So we're going to go ahead and set up our equation. We're going to do our x2 or our y2 minus y1, which is 7 minus 2, and our x2 minus x1, which is 4 minus 1. When we go and solve for that, we're going to get 5 over 3, and that's actually going to end up being our slope for the 2 points. And that this graph right here is just a representation of what our line would look like. Thank you. Allison, is there a way to check your work?
Yes, there is. Okay, so Elizabeth just took our points and plugged it in and came up with our slope, which is 5 over 3. So we are going to use the numerator, which is 5, and we are going to count up 5 from our lowest point down here, which is 1, 2. So up 5, 1, 2, 3, 4, and 5. And then we're going to go to the right 3, 1, 2, and 3. And that comes to our next point, which is 4, 7. So now we know that our slope is correct.
Good job, Allison.
So Molly, can you describe the slope of the given line?
Yes, so looking at the trend of this line, it's easy to see that this one does slope upward to the right. So it is increasing on both the X and Y axis. And another point to make about this is because the slope is positive, both integers are positive, that means that it is always going to be increasing upwards to the right. So that is a note to keep when looking at slopes.
Good job, Molly.
Thank you. Okay, question number 4. Create a table to solve for y equals x squared minus 7 using all values between -3 and 3. Create a graph for the function. Okay, so on this one, you are basically just using the input-output method. So right here, you've got all your values between -3 and 3, and they are there to represent x. And then over here, you've got the outputs, which is y equals x squared minus 7. And so after plugging in each of these values into this equation, these are the new output values that you are going to be using when plotting your points. And so this parabola right here is actually the graph for the line y equals x squared minus 7.
Did a really good job.
Thank you. Okay, Elizabeth. Create a table to solve for x squared using the numbers 0, 1, 2, and 3. Use the table to create a graph for the function.
So what I went ahead and did, I created a graph or a table for my x and y, and I just plugged in some random points for my x, 0, 1, 2, and 3, and just plugged them in for x. So if x were 0, x squared would just be 0 times 0, which is 0. Next for 1 times 1 is 1, 2 times 2 is 4, and 3 times 3 is 9. So we have the points 0, 1, 4, and 9. And what you can do to kind of help you out a little bit is go ahead and get the negatives for these two. So -1, -2, and -3. And eventually, you'll get a graph that looks like this, where your 0 hits at the bottom of the graph, and you just kind of get a curve from in between your x and your y axis that is mirrored. So
Great
Allison,
job.
thank you. Allison, create a table to solve for y equals x squared plus 7. Create a graph to represent the function.
Okay, so this is kind of repetitive, but my function is different. So here are my x's, and I took -5 through 5, and I just went on ahead and plugged them in to my function. And my y is the output. And I just went ahead and plotted my x and y points and came up with this parabola over here to the graph on the right.
Good job.
Thank you. So Miranda, what is the relationship between the three graphs?
Okay, the relationship between the graphs, they are vertical shifts of the same curve. As we look at the yx square, we see that it is a perfect U that Elizabeth has done. And then we come over here and we have Allison's graph, which is x squared plus 7. And again, you see that it's just a little bit different. You notice that it's just shift up 7 units. And then you come down to the one that Molly did and yx squared minus 7, and you notice that it just shifts down 7 units. And that is the relationship between the three graphs.
Great job explaining that.
Thank you. Question 5. Allison, what is the slope of the line that is perpendicular to y equals negative 1 over 2x plus 2?
Okay, so first things first, we have to find the slope of our given line. So the slope of y equals negative 1 over 2x plus 2 is going to be negative 1 over 2. And to find the slope of the perpendicular line, we have to find the opposite reciprocal of negative 1 over 2. So what we're going to do is we're just going to simply flip our numbers and change our sign from a negative to a positive. So our slope for our new perpendicular line is going to be 2 over 1.
You did a really good job on that one, Allison.
Thank you. So Elizabeth, can you find the equation that represents a line that is perpendicular to y equals negative 1 over 2x plus 2 and goes through the points 5, 0?
So what we're going to do, we're going to start out with our original equation. We have y equals negative 1/2 x plus 2. In order to find the perpendicular line, we're going to want to find the reciprocal of the slope. So we're going to do the same thing that Allison just did a minute ago, and we're going to flip our negative 1/2 to where it's 2 over 1, or 2. And then we're going to change our sign from negative to positive. So we should have 2x plus 2. Well, next we want to remove our 2 out of the equation just so that we can figure out a number that better works for our equation so that our line goes through 5, 0. So instead of having the 2 there, we're going to go ahead and put b. And our new equation should be y equals 2x plus b. So then what we're going to do is we're going to plug in our point 5, 0, 5 being x, 0 being y, where we have the equation 0 equals 2 times 5 plus b. 2 times 5 is going to be 10, so 0 equals 10 plus b. Now we want to solve for b. So we're going to subtract 10 from both sides, and b should be equivalent to negative 10, meaning that our equation is going to be y equals 2x minus 10.
Good explanation.
Great job.
Molly, show how the graph, or the graphs, how to graph both the original and perpendicular lines.
Okay, so for the original line, you can see that this is the line for the equation negative 1/2 x plus 2. And again, talking about what I mentioned earlier, when you've got a negative slope, it is going to go in the negative direction because you've got that negative value. So this one is actually going to the left upwards, and then you look over here at the opposite line, which is perpendicular. This is y equals 2x minus 10, and this one is doing the exact opposite. It is actually sloping upwards to the right, and these two lines come together at a perpendicular angle, so that is why they look similar, but they are going exact opposite directions.
Good job.
Thank you. Okay, Miranda, explain how two non-vertical lines are perpendicular if their slopes are negative.
Okay, two non-vertical lines are perpendicular if their slopes are negative, if they're reciprocal of the others. If we look at our answers, m equals 2 over 1, which is positive, we're going to see that it's going to go to the left upwards. And if we look at our other one, which is y equals 2x minus 10, which was negative, then we're going to see that it's going to go to our right. And any vertical line is perpendicular to any horizontal line, which causes us, we should find the slope of that perpendicular line within both of our equations that Elizabeth and Molly and Allison have discussed in this question. Okay,
Good job.
thank you. Now we're going to go to question 6. Elizabeth, what does tangent mean and how do you find the tangent lines in circles?
So tangent lines on a circle are pretty much just lines that only touch the circle at one point, and they create a right angle or they're perpendicular to the circle's radius. So for example, I have a circle right here. If you'll notice the orange line outside of the circle, that's actually going to be the tangent. Just because it's perpendicular to the radius, it creates a 90-degree angle and it only touches the circle at one point. Again, I have a circle to the right. It has points 0, 0 for its center and 0, 3 for the edge of it. Based off of these points, we know that the radius is going to be 3. And if we look right here at our green line that just popped up, it hits that circle right at that point. If you'll notice, based on that red square right there, it creates a 90-degree angle with the radius, which means it is perpendicular, and it also only hits that circle at one point, therefore it is going to be tangent to the circle. Allison, with a radius of 9 and an origin of 0, 0, what are the 4 points that make up the circle?
Okay, so we are going to start at our origin, which is 0, 0, and our radius is 9. So we are going to count 9 points in every direction to come up with our 4 points. So starting at the origin, we're going to go to the right 9 points, and our point will be 9, 0. We are going to go to the left 9 points, and our point will be negative 9, 0. Up 9 points, and our point will be 0, 9. And then down 9, and our point will be 0, negative 9. And then we're going to connect all those points, and there's our circle.
Good job, Allison.
Thank you. Okay, so Molly, show the tangent line of a circle with a radius of 9 at point 0, 9, and whose center is at the origin.
Okay, so looking at this one, this is just kind of giving another example of finding the tangent of a specific point. And so we go up to 0, 9 right here on the y-axis. And as you can see, this line is tangent just because, for one, it is the only point that the line touches on the circle, and as well as the fact that it is going to be perpendicular to the circle's radius. So that is the tangent line for point 0, 9.
I really like
Great
your
job.
visuals on that one, Molly.
Thank you.
Oh, we have a graph in the way.
Yes.
We're going to fix it.
Um,
I think that was just a presentation error.
it's down.
You're good to read it off.
Okay, Miranda, compare the line in part B to the line in part A.
Okay, so we will recall in part A that our answer was a negative 9, and in part B, our answer was 9. This is, okay, remember that 2 lines are parallel if their slopes are equal, and 2 lines are perpendicular if their slopes are negative reciprocals. So this will give us the tangent line of the 0, negative 9, and 9, 0. And notice that both lines have the same slope, and therefore the 2 lines are parallel. And both of our answers that Elizabeth, Molly, and Allison have discussed in the last question.
Good job.
Great job.
Okay, so this is the end of our presentation. We are the Unstoppables. Thank you for watching, and we'll see you next module.